Hello, everyone. This video is on the covers the prerequisite skills that are critical for Module 4, especially in this first task here. So the first thing we're going to talk about is domain and range. This is a review from Math 1, and you did a little bit in Math 2 also. So domain is the set of x values that covers the graph, okay? And the range is the set of y values that cover the graph. The only thing is in the past we use like set notation, and now we're going to be writing it using inequalities, so it may be a little bit different. Okay, so let's take a look at a couple of examples here. Okay, so for the domain, if I look at where this graph covers the x-axis, right, what x values are covered? Well, I know it starts on the left and it continues all the way to the right. So we used to say that this goes from negative infinity and then ends at 2. Okay, but now we have to translate this and write this as an inequality. Well, if we look, if it's equal to 2, we know all the x values that are on this graph are to the left of 2, so we say less than or equal to 2. Okay, now the range, when you look at the range, it covers the y values. Okay, so since this starts at the bottom, right, the range would start at -2, and then it would go all the way up and continue to positive infinity. Well, what do we say about this? And we say all the y values, since they're above -2, we say are greater than or equal to -2. Okay, so the inequalities are a little more difficult, but you should catch on pretty quickly here. So the domain for example 2, since it starts at 0 and it goes to the right forever and ever, what could we say about these x values? Well, I'm going to say x is going to be greater than or equal to 0. And that's because all the values in the graph are to the right of 0. Now for the range, if I look, here it goes down forever and ever, and then it goes up forever and ever. So all we're going to say is all real numbers, okay? Because all the numbers on all the y values are covered on that one. Example 3, the domain here, okay? The domain, if I look from left to right, what does this graph cover? Well, the farthest left it goes is at -2. The farthest right it goes is at +2. So we're going to say the domain is between, right, two numbers. And we're always going to put the big number on the right and the small number on the left. And that's because we're writing a compound inequality. So if you look at this, we're going to say x is greater than or equal to -2, but it's less than or equal to +2. Now when we look at the range, right, we start at 1 and we go up to 5. So we're going to say all the y values are greater than or equal to 1, but less than or equal to 5. Okay. Again, you've done domain and range. Inequalities may be a little bit new, but we're going to be hitting this a lot as we move along. Okay. Now, writing equations of lines. First off, all the lines we write are going to be linear functions. So you're going to look for that common difference or slope. So linear function is a function whose graph is a straight line. In slope intercept form, it is y equals mx plus b, and then point slope form is y equals m, which is a slope, times x minus x1, all plus y1. The important thing to know here is m is a slope. And if you remember, that's a rise over the run, or what do? We do y2 minus y1 over x2 minus x1. All right, and when we plug a point in here, you have to understand it's minus inside here, and the values you're going to be substituting in for are x1 and y1. So how do we write equations in equations of lines. One, we find the slope. Then we write the equation in point slope form. It's easiest to start with that one. And then 3, distribute and simplify to write it in slope intercept form. So let's take look at a couple of examples here. Write an equation for the line that has a slope of -4. So right away, I'm going to write m equals -4 because that's the slope. And passes through the point -3, 6. So what we're going to say is this here is x1, this here is y1, and we're going to plug all of that in to point slope form. So y equals, my slope is -4, times x minus, this is where I'm going to put this x1 in, -3, all plus y1, which is 6. Now what you have to understand is when I subtract a negative, that becomes a positive inside. So when I simplify that, I get -4 times x plus 3 plus 6. This here is point slope form. But now we want to take that and write it in slope intercept. In slope intercept, the first thing I'm going to do is distribute the -4. So -4 times x is -4x. -4 times 3 is -12, then plus 6. And now if I combine like terms here, I get -4x minus 6. And this is slope intercept. So here this is point slope. This here is slope intercept. Okay, so when we look at the next one, write an equation for the line that passes through the points, -6, 19, and -1, -1. Well, they don't give us a slope in this one, so we actually have to go and find it. So remember, we're going to do y minus y over x minus x. So I'll start with 19 minus -1 over -6 minus -1. Since I'm subtracting negative on top, I add it. Subtracting negative in the denominator, I change it to addition, and I get 20 over -5. Now this could be reduced to -4. Now, it doesn't matter from this point. They give you 2 points. We're just going to pick one. All right. So first thing we're going to do is write it in point slope form. So y equals, my slope is -4 times, we're going to go x minus -6, and then that's going to be plus 19. Now we should change this to plus positive, and this would be your point slope form. Now when we go to write this in slope intercept, okay, first thing we do is we distribute the -4. So -4 times x is -4x. -4 times 6 is -24 plus 19. And when we simplify here, you get -4x minus 5. And that would be your point or your slope intercept form. Okay? And again, this is all a review, so if I'm going quickly, you can pause, rewind it, and I'll be in the class to answer questions. Okay, the last one, right? First thing, write an equation for the line that passes through the point 0, 8, 6, 12. Well, we're going to find the slope. So we do 8 minus 12 over 0 minus 6. That there would give me -4 over -6. And when I simplify this, I would get 2/3. So we'll start by writing it in point slope form. Does not matter which point you use. You can use either one. I'm going to use 6/12. So point slope first, y equals 2/3 times x minus, I'm going to do 6, and then plus y1, which is 12. So this here is your point slope form. And now my slope intercept right? If I distribute the 2/3, I get 2/3 x. 2 times -6 is -12, divided by 3 is -4 plus 12. And that would give me 2/3 x. Then this would give you plus 8. Now, looking at that, this would be your slope-intercept form, but the nice part about this problem is they give you the y-intercept. And remember, when we have y equals mx plus b, m is your slope, b is your y-intercept. So if you recognize this is your y-intercept, you could just put 2/3 x plus 8. Okay, example 4. First thing we want to do here is find the slope. Okay, so if I count the rise over run, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. So you get -5 ninths. All right, just double counting. Oh, 5/8. Now I'm going to gather an ordered pair here. Say 3, 1 that they give us. Okay. When I look at that, I'm going to write it in point slope form first. So you get -5/8 times x minus 3 all plus 1. Now, this is going to give you a real ugly number, so I would not expect you guys to go and distribute this and write it in slope intercept. I'll take either form. Now, a vertical line. If you guys remember, the equation of a vertical line is one single variable, and it's always x equals a number. Okay, so what does x always equal here? X is always equal to -3. So the equation of a vertical line is just x equals -3. Now when we go to a horizontal line, remember, that's always y equals a number. Okay, and what is the repeating number in this case? 4. So y equals 4 would be the equation of that line. Now when we graph a line, we find a point on the line, plot the point, and then we use the slope to find the second point. Okay, remember, in slope-intercept form, m is the slope, b is the y-intercept. Point-slope form, right, y equals m times x minus x1 plus y1. You get m is the slope, but then you get a point, which is x1, y1, but you want to think the opposite of x1, because when you pull it out, that sign's going to change, and y1. So the first example here, right away, I know this is the y-intercept. So I know a point is 0, 7. So I'm going to go ahead and I'm going to plot that. And I know my slope is -3/5. So that's going to tell me to go down 3, right 5. So from here, I go down 1, 2, 3, right 1, 2, 3, 4, 5, plot my point, and then I go ahead and graph the line. Okay, the next one, when I gather my ordered pair first, I take the opposite of -4, which is +4, and then -6. So I'm going to plot 4, -6. My slope here is 3. Put that over 1. That tells me I'm going to go up 3, right 1. So from here, I go up 1, 2, 3, right 1. And I can continue this slope, and all these points will line up in a straight line. And the last one here, the opposite of 1 is -1. My y value is 2. So I'm going to plot -1, 2. Now my slope here is 4/3. Since it's positive, I go up 4, then I go right 3. So up 1, 2, 3, 4, right 1, 2, 3, plot my point, and graph the line.